Today I'm going to jump into the most effective AI reinforcement learning tutorial that you've probably ever seen, and it's for beginners. So let's go. Hi everyone, I've been studying Python and AI for the last 8 years, and in this quick tutorial, I want to show you one of the most advanced algorithms, which is reinforcement learning. This is an AI algorithm that learns by itself and bashes into walls to learn things from first principles, versus a lot of AI algorithms that exist now, like you'll typically see from chatbots, that rely on learning secondhand information from humans and the internet. Reinforcement learning learns by doing and is one of the most popularized algorithms nowadays. I want to show you in this first tutorial a simplified way of using what's called Q-learning in order to use this reinforcement learning, but for stock prediction. And I'll show you that in a second. We're going to be using reinforcement learning and this Q-learning method in order to predict stock prices for Tesla and hopefully make some money virtually. Now this isn't this is a warning. This isn't financial advice. Please take everything with a pinch of salt, and all risk is your own. So let's jump into it. Hi everyone, note this isn't financial advice, all risk is your own, and this is just for educational purposes. So now let's jump into it. So now in order to start the tutorial, I want you to stop what you're doing, and whether you're on your phone or your laptop, I want you to go to Google Colab. So you can do this by typing in Google Colab into the search bar, or typing colab.research.google.com. And what Google Colab is, it's like a Word document or a Google Docs, but for writing your code. So we're going to create a new notebook, and I'm just going to zoom in. And the first thing I'm going to write is our first RL, which is reinforcement learning. So I'll type in our first AI RL tutorial. And this is for Tesla stock prediction. And so the first thing, if you haven't already, I would highly recommend that you go to one of my Python tutorials. If you have a base in Python, feel free to follow along. I've created other videos when it comes to AI, but knowing Python is foundational before learning these other AI concepts. So what we're going to start off with is imports. When it comes to AI, there's a bunch of really smart people that have already done things for us. So we're going to start off with, and just hold on with me for this part, we're just going to type in a few imports that will help us do what we want in this tutorial. So I'm going to start off by import NumPy as NP. So NumPy is a very typical data analysis tool that allows us to store things, for example, in tables and data, and a lot of data, and do a lot of data analysis functions. Next, we're going to import random. This allows us to create random numbers, and you'll see why that is relevant within reinforcement learning. And next, we're going to import yFinance. So yFinance is short for Yahoo Finance, and this is where we're going to get all of the stock data for Tesla. And last but not least, we're going to import the very famous matplotlib. And so we do import matplotlib.pyplot as PLT. So what this is, it's a plotting library. So there we go. That is all of the imports we'll need today: NumPy, random, Yahoo Finance, and matplotlib. So the first thing I'm going to do is just run this. And if it's all successful, we shouldn't get any errors. And last thing I'm going to write here is a comment. If you remember, like Twitter or X, we write comments with a hashtag. So we write hashtag imports. And that is our first thing that we have to do before we do anything else. Next, I'm going to add another code block. and this is just our continuation or what we do next. And as I said, we're going to be using reinforcement learning, and what I want to see in this tutorial is how does it compare if we randomly hold a stock or buy and sell versus we use this reinforcement learning algorithm. And first of all, I'm going to import all of the Tesla finance data. So Tesla finance data imports, and I'm going to do like the last 10 years. So in a new line, I'm just going to write Tesla stock prices, which is Tesla prices, equals YF, which is Yahoo Finance, dot download. And then the Tesla stock ticker symbol is TSLA. Then we do the period. So the period is 10 years. And then here at the end, I do a square bracket. And in quote marks, I write close with a capital C dot values. So if I now print this out, dot head. Oh, it doesn't have a dot head. Let me remove this. Here you can see a list of daily prices of the Tesla stock for the last 10 years. And this is closing prices. So at the end of the day, this is basically what the price is for every day of the last 10 years. So there we go. We've imported the Tesla stock data. Second of all, we're going to create a simple trading environment with $500. And this is simulated. So this is, again, not financial advice, but this is basically the environment within reinforcement learning. How it works is you create an environment. Think of it as like a baby, right? And you release it into the world. The world is your environment, right? The baby can take actions. It can be in certain settings. And so think of it as the exact same when it comes to this AI reinforcement learning algorithm. You're launching it into a world, and here we're creating the world for it that it can use to interact. So we'll start off by writing class. This is basically a structure that we can use to define this world. This world, in this case, is going to be a trading environment. So we write trading environment, colon, and this is what we use in order to create the environment. Next, we're going to start by doing def underscore underscore init underscore underscore, and then we write self and stock prices. So what we're doing here is we're initializing this is called a constructor. It's basically when you define this environment, what are the default values that you want to exist? So the default values is self.stock prices. So we want to feed it the stock prices like those of Tesla that we've put up there. And we're going to do equals stock prices. Next, we'll do self.initial capital. So this is how much money are we starting off with, right? And I said right now that we'd start off with 500 bucks, right? So I'm going to write 500 and I'm going to do .0 to make sure that we're working with decimals here as well. So we've basically said, here's our trading environment. We have stock prices. We have initial capital. What else do we have to define? We have to define the max steps. So think of this as if we do stock prediction day by day, how many steps can we do? Well, we're limited by the amount of days of stock data we have here. So we're going to say the maximum is equal to the length of the stock price data, right? We can only try to estimate as much as the stock price data. But if you think about it, you can only compare if you have 2 days. If you have today and tomorrow and the next day. You can only analyze the difference between 2 days at a time. So it means if you get to the last day, there's no other day to compare to. So we're going to remove 1 because you can only compare in pairs. And when you get to the last day, it can't be compared to anything else. And the last thing we're going to do here is self.reset. Basically, all this is doing is saying, if I create a new environment, I want the old one to reset. So there we go. That is our first function here. And this defines all of the defaults of stock prices, capital, max steps, and reset, but it's not really doing much. right? So let's start to define other functions within this environment that will help us create this reinforcement learning environment. So we'll start off with one called reset. So we've said here, reset, self.reset. What does this actually mean? So we do def reset and we write self here. And next, I'm going to first start off with the current setup. So self.current step is 0. Basically saying, hey, we want to predict it day by day, but we start at 0. This is a very basic thing to define. Then what we want to say is, hey, when it comes to stock trading, let's simplify this. We have $500 and we have 3 actions, right? Let's say when you're giving an AI algorithm something to do, you have to say, what can it do, right? How many actions can I take? So we're gonna say, for simplicity's sake, you can only take 3 actions, which is you can buy stock of Tesla using this $500. You can hold it, meaning if I've already bought it, I'm not going to do anything. I want to hold it, and over time I assume it'll accumulate. Or the last thing is I can sell it, but I can only sell it if I have I've actually bought it before. And likewise, I can only buy the stock if I have money left, right? So some of these actions depend on different circumstances, but in general, we just have 3 actions: buy, hold, and sell. So what I'm going to do next is I'm going to start off with, when I start at the very beginning, I start with $500 and I start with 0 stocks of Tesla, right? So I'm going to write self.own_stock equals false, as in we don't own stock of Tesla at the very beginning because we've just been given this $500. Next, we're going to do self.capital, and this is the amount of money that we have, right? And if you remember at the beginning, we start off with this amount. So I'm just going to copy the self initial capital, $500, and I'm going to write it here. So that is the that's the capital that we start off with. Next, we tried to say how many shares we have, right? A share is just a stock. So at the beginning, I'll have nothing, but if the algorithm decides to buy some stock, I'll have some left over. So I'll write self.shares equals 0.0. And similarly, we can say buy price equals 0. So at the beginning, we'll assume the price is 0, and then we'll return the self.get_state. So this is, in reinforcement learning, you have a state, which means you take actions, and after that actions, you have a certain state. There's a consequence to that, and like today, if I take an action, tomorrow I'll be in a certain state. And so we'll define exactly what a state means. But in reinforcement learning, you can think of there being states and actions. Like Newton's laws, there is for every action, there's an equal and opposite reaction. You can think of, you have an action and then the reaction, right? So next we're going to write the get state function. You write get_state self : So that's how we define the function in the class. And we're going to start off by saying, okay, if we start off at the very beginning, what happens? So if self.current step, which means at what step am I in, what day am I in the trading process? If it's 0, which is that I just started, what it's going to return is self. So we're going to define the environment or the state as 2 things. Basically, how much stock that you currently have, right? So here we do or if you own the stock or not. So self.own stock, and then also the profit. So here we do 0.0, right? So that's how much money that we have so far. So here we have self.own stock and then 0.0, and that is how we start off. That is the state that we start off with. But how does this change? So what changes is the price, right? The price of the stock. So we're going to define the price today, And the price today is equal to, we're going to say, first of all, float. So float is basically saying, hey, we want this in decimal places because money comes in decimal places. And then we're going to grab from the stock prices. So here we had defined all of the stock prices, right? And this is going to come from here, the Tesla data. And we're going to say the price today is the stock prices. And we're going to then grab the current step. So the current step is what day we're at. So self.current step, which we grab here. Right now it's at 0, but you can imagine how this progresses. And that is basically the price today. It is the decimal version of the price given the current step or the current day. Next, we're going to look at the price yesterday, right? So if we want to compare two prices, we look at the price yesterday. And we do price yesterday is float, and then we do self dot stock prices. So we do something very similar. We can probably even copy paste this whole line, but instead of the current step, we do current step minus 1. And that's how you get the day before, right? It's the same day, but minus 1. And the last thing is we're going to return the state, right? So at the very beginning, we said we own the stock, yes or no, and then this is the price. And what we're going to return here is the same thing. Basically, do we own the stock right now or not? We're going to pretend that there's basically only two possibilities. You either decide to own the stock or you sell it. There's no kind of in between. And this is just for simplicity, but just bear with me. So same thing, we define the current state as owning the stock. But when it comes here, we're going to basically look at how much profits that we have, right? And we're going to do it rounding. So this is just rounding the current price. And we're going to say, okay, what is the difference between the prices, right? So what is the difference between the price today minus the price yesterday, right? What is the percentage difference in the price, right? So the price today minus the price yesterday divided by the price yesterday. This is how you typically find, this is the equation for finding the percentage difference. So the price today minus yesterday, let's say today was 110, yesterday it was 100, the difference is 10, and divided by the price yesterday, which is 100, is 10 divided by 100, which is 10%. So this means that the price went up by 10%, and this is the equation for finding the differences in price. And typically when you look at a stock chart, that's what it shows. It shows the difference in percentage of the price day by day. And I'm going to round here to 4 significant figures. So that's pretty much it there. We've defined the state, whether it's at the start or later, depending on the day by day price. And the last thing we're going to do is we're going to define a step. So a step means just a day by day, the actions that the algorithm is taking. So we'll do self and action. These are the arguments that are taken in. And I'm going to write here chosen action. So the algorithm can decide to take an action every day. We're then going to say, okay, what happens every step? What happens day by day? A day goes by, right? That's pretty obvious. So we're going to write self.current step plus equals 1. This just means that every step, a step is taken. Very simple. Next, we're going to write simulation underscore done is equal to self.current step. So is greater than or equal to the self.max steps. All we're saying here is, okay, when does this finish? This finishes when we run out of days of stock prices to go through, right? So this will be true if we've basically finished. And then we'll start off with the profit. How much profit have we made? It starts off with absolutely 0, right? Not very good. But what we do is we do current underscore price is equal to the price on the first day. If you remember that was here. So we start off at 0 and we do the current price, which is stock prices at the current day. And basically we do if the chosen action at the very beginning is 0, if the chosen action is 1, and we're going to say 1, 2, and 3 is our possible options. The first action is, we're just going to assume that the first action, number 1, is buying, right? So here I'm going to write in the comment. The actions are number 1 to buy, number 2 to sell, and anything else, which is 0, is to hold. And so what we're going to do is, if the chosen action is 1 and we actually have enough money and we don't own the stock, we write and not self.own stock, then we can buy it. So really simply, we say if we've chosen, the algorithm is chosen to buy and we don't already own the stock, let's allow it to buy. And how do we do that? Very simple. We say self.own stock is true. So this means that we're saying, yes, we do own the stock. The next that we're going to say is how many shares, right? So we write self.shares equals self.capital. So this is the capital that we have available divided by the current price. So basically, if the stock costs $500 and I have $500, how much shares do I have? 1. So very simple. Next, we're going to write self.buy price. What is the price that we're buying at? It's the current price. So very simple. And then last, we're going to say how much capital do we have? If we've spent all of our money on stock that day, we have our capital is 0. So basically just saying, okay, we've bought it all, but what is the consequence? We have 0. So at the end, what we've said is if we are buying, we own the stock, we own this many shares, we buy at this price, and then our capital becomes 0 after that because it's invested. But what if we sell? So we say else if the chosen action instead of 1 is 2, which is to sell, and we do own the stock because you can only sell if you have the stock. What we do next is we write the profit. So when we sell the stock, we actually make some profit, right? And so the profit that we have is self.shares. So the amount of shares that we have times the current price. And this is the, so the amount of money that we've made in profit is equal to the self.shares.current price minus self.shares times the buying price, right? So how you find the amount of money that you made profit is how much did I spend when I bought it minus how much are the stocks worth after I sell them. So that is the profit. And then we do self.capital equals self.shares.current price. So this is the amount of money that we now have available and we can invest if we want, right? This is the money that we earned after selling all of it. It's different from the profit because we started off with a certain amount invested. Then the amount of shares that we have at the end of the day is 0. And do we own the stock? No. After we sell it, we do not own the stock. So we write false. And that is pretty much it for those 2 steps. We can buy, we can sell, there's certain consequences to that, but we can also hold, right? And so if the chosen action is 0, it's none of those. What we can write is return, is basically nothing happens, right? So we write at the end, return self.get_state. We return the profit, the simulation done, if it is done, and then the info directory here, which is nothing. So what we've just done is we've defined this trading environment fully. So we've started with the initial piece, we reset the state whenever we start again. We define the state, which is the current, if we own the stock, and also here the percentage change, right? And here a step, and each step you can buy, you can sell, or you can hold, which is to do nothing. So that is pretty much it. I'm going to run this now, and as you see, it's worked good. And now we're actually going to define the third step. And there's only one other step, a few other steps after this. And so we're going to define the Q-learning algorithm. This is the algorithm that basically is the reinforcement learning one. And it's going to be very simple. All we're going to do is two things. We're going to randomly choose at the beginning. And every time that we randomly choose, the algorithm's going to learn what decisions were good when there was a certain state and what decisions were not so good. And all we're going to do is we're going to have this massive book, let's say a table, with all of our learnings. And basically as the algorithm goes learning and doing random choices, it does some exploration, which means it does random choices and writes those down in this table of knowledge or in its brain. And sometimes it's going to do exploitation, which means, hey, I already know from this table what good decisions are. Let me use those good decisions. So here I'm going to define, first of all, this Q-learning algorithm. And I'm going to start by defining the chosen action. So I do chosen action here is current state, Q table, Q underscore table. This is our table of knowledge as the algorithm goes learning, and exploration rate. And so this is the function. And if I write if random dot random, so this generates a random number, is under the exploration rate, and you'll see that in a second. So if we randomly choose a number between 0 and 1, and if this is under our threshold of exploration, let's return a random number, which means, hey, let's explore, right? So here we have 0, 1, and 2, which are all the possible actions, right? 0 was holding, 1 was buying, 2 was selling. And then here we're going to return int np.argmax, which is the maximum, right? Q underscore table. So all we're doing here is we're saying, hey, let's reference this table of knowledge that this algorithm is going to be building by randomly hitting walls a ton of times, but then making mistakes and learning from them. And we're going to do current underscore state np.array. And we're going to do 0.00, comma 0.00, comma 0.00, which is basically an empty state. So we basically say, given the current state, and if it doesn't exist, then return zeros all around, right? So this is how it chooses actions. Sometimes it chooses them randomly. Sometimes it uses this table of knowledge that it builds up. Next, we're going to do def update Q, which is updating this table of knowledge. And the arguments are under Q table. It's current underscore state. It's chosen action, profit, next state, learning rate, which is the amount that it learns, and the discount factor. Just hold on with me. I know this is a long function, so we're just going to go like this, and that is how we've defined it. So that long function is now defined. If we do if current state is not in the Q table, so if we come across a certain state and we've never seen this before, what do? What we do is we add this knowledge to the knowledge table, which is the Q table. So we write Q table current state. No, actually, so what do we do if it's not in the table? What we do is that we just initialize it with nothing in it. So we do np.array 0.00, and we write this 3 times. And these are the 3 different states. So that's what we do if we haven't seen it before. If the next state is not in the Q table, so if the state after, right, which is after we've taken an action, right? So we know the past action we took and we know the consequence. So let's look at what happens as a consequence. So we do qtable next state equals np.array 0 as well. So we say, okay, if we haven't seen the current state, if we haven't seen the next state, let's define these both as 0. But what happens when we have seen the current state before and we've seen the action, right? So if we've been here before, what do? So we do chosen if this table that has all our knowledge has seen this current state and this action before, what can we do? So what we do is we do plus equals learning rate. So this is the rate in which it learns. We don't want one single example to suddenly mean that the model just does everything according to a single example it's seen. So we add a learning rate, which means that it goes updating on a certain amount. And we write the profit, which is the profit that we made in that moment from that action, plus a discount factor, which means it doesn't over rely on that factor. And we do a discount factor times np.max, which is the maximum amount, np.max of the Q table, which is the last result that we had when we did that. So we do Q table Q table, and then we do next state, which is the state after, right? So we discounting given the next state. And let me just go there, minus the Q table current state. So here we just see the difference of the profit now versus the profit later, and given the chosen action. So there we go. We have the Q table given the state after. We have the Q table given the current state minus the chosen action. And this difference times the discount factor and the profit makes us estimate what would happen if we, given the current state, take a current action, right? So this is how we update Q, and we update this knowledge graph, this knowledge table. So there we go. That's how Q learning works. We've defined basically this table that accumulates knowledge. And next we're going to set step number 4, the hyperparameters. These are the parameters we're going to use in the training. Like how much is it going to learn? How does it, what is the state and everything? So for this, we're going to write the episodes. So you can think of episodes just like in cartoons or in a TV show. This is basically like the amount of single iterations of training. So it's going to go through the algorithm's going to go through all the days of the 10 years. And how many times should it go through those 10 years and go learning, right? The more times you've seen something, the better it'll be. And here, just hold on with me. We're going to define many variables. So we're going to write the exploration rate. We're going to write the minimum exploration. We're going to write the exploration underscore decay. We're going to write the learning rate, the discount factor. And these are all of the variables that you need in reinforcement learning. How much it's going to explore, the minimum exploration, how much the exploration should over time, as you've already learned a lot, go diminishing. The amount that it should learn, and a discount factor is how much it should discount the rewards. So here, if we define these, we're going to define the exploration rate to be 1 at the very beginning. We're going to put 0.1 as the minimum exploration, so it should always explore. And the exploration decay is going to be 0.997, which means over time, it should explore less and less and rely on its own knowledge. The learning rate is going to be 0.2, the rate at which new data changes, and the discount factor is 0.99 for rewards. So that's pretty much it. Now we're just going to launch, create our environment, which is environment equals the trading environment, which is what we put up here. And so we do trading environment here. And then we do Q underscore table, which is our original knowledge table, and we're going to define it as empty. So that is pretty much all you have to do in order to define it. And we're going to write one other one, which is RL underscore agent rewards, which is the amount of reward, the record profit from each training round. So that's how we define it. Cool. Now what we're going to do is we're going to do a training loop. So we've defined all of these parameters. Let's actually train this model. So we do for every episode, which, if you remember, was the amount of iterations we want it to learn from the data. So we say for episode in range episodes. So what we're going to do is for range in episodes. So we look at all of the episodes and we say the current state at the very beginning of each episode is we reset the environment. So what this means is, hey, let's start the canvas fresh, but let's use our learnings that we've accumulated and have this knowledge, and we just start at a better baseline. Imagine, for example, you run a race, and then you run the race, for example, here 100 times, and you have knowledge that you've built up per race, but each race is a new race, right? So we reset it. Next is we write the episode. Next is that we write the episode total profit. So how much profit have we made so far? So we write 0.0, and then we write, is the simulation done? At the start is false, right? So we reset this because the simulation will be done, but then it has 100 simulations to go through. So here we write false, and we write while not simulation done. And then we write chosen underscore action equals choose action, right? So it should choose an action, and it should do this according to a lot of stuff. So how does it choose an action? It needs to know the current state. It needs to know the Q table, so the knowledge table, and it needs to know the expiration rate. So there we go. We've typed that all in. And that is it. But next, what do we want? So it chooses an action, right? And what happens when an action is chosen? So when an action is chosen, it should actually, sorry, instead of choose action, it said chosen action. So here we write chosen action, right? And so it chooses the action. And then what's the consequence? So we then have a next state from that action. We have the profit. And we also have the simulation is done or not. And then we have an extra variable, but let's just put underscore here because it's not going to be used. And then we write environment. So given the action that we chose, what do? Environment dot step given the chosen action. So we take one more step given the action that we chose here, and then we get given this next state, profit, simulation done, etc. Right? And then all we have to do is then update our knowledge table, update underscore Q. And this is how we update that table of knowledge, given that we've bashed into a wall here. And we do current states, Q table, current state, chosen underscore action. We then do profit, next state, learning rate. Let's see if you can see this all, learning rate, and discount factor. And there we go. That's all we have to put there. Here it's gotten ahead of myself with the autocomplete, but here we have update queue, right? And so it's updated the knowledge table. Then we write current underscore state equals next state, because the state from yesterday is now today's state. And then we do how much profit did we do, right? So episode total profit plus equals profit. And that is how we go accumulating this profit. Next, we write exploration underscore rate is maximum of the minimum exploration rate, right? So this is the minimum rate that we have to explore. But every day that goes by, we want to explore less because we've learned a lot and we want to rely on that knowledge, right? You wouldn't be doing anything new if you didn't have the minimum exploration rate. So here we write just minimum exploration, and then we write exploration rate, and that is exploration rate times the exploration decay, because this is the decay that I was talking about. Every day we're going to be exploring less because we've already explored a lot. Then last thing I'm going to write here is RL agent rewards. How do we reward this agent, right? At the end of the day is .append episode total profit, which is this part. So that is the total reward. And let's just say here that we don't want to be updated every time this does a simulation. And instead here we write episode plus 1 percentage 100 equals 0. So every time that there's 100 episodes, we want to just be told about it. So here we do printf episode. We put curly braces episode plus 1 because it's 0 indexed, divided by episodes. So this is the total, like it'll say like 1 out of 100 episodes done, for example. And then we write the total profit here, which is episode total profit. And we're just going to do the 2 decimal places like this. Cool. So that is pretty much it when it comes to, you've now actually created proper hyperparameters and training. And the next and last piece is we're going to have to compare this to something. So 5 is here. Compare, evaluate versus baseline. So what is so we've just done like a really good like algorithmic trading strategy, but what does it look like if we did a dumb one? Because I want to compare this. And dumb one sometimes is actually better. When you hold a stock, it's shown to be really good, right? Because if the stock goes up, then you're in a great position. But if I do baseline shares is 500, right? So we have $500 divided by float. Tesla prices 0. So this is like the holding, right? If I buy at the very beginning and I just hold, what is the profit, right? And so it's a very easy calculation because you just look at like the baseline cost of your shares and then you multiply it by the last price, right? And then you minus 500, which is the original, right? So this is how much shares I started off with buying. This is the final price, and this is minus the first investment, and this is the profit I have if I hold. But what if I do like a random strategy, right? Let's compare this to like random strategy episode. And the way I do this is environment.reset. So I reset everything and I return the sum of the environment.step. But instead of like learning or doing anything, what I'm going to do is I'm going to take a random action every time, right? So I do random.choice between 1, 0, 1, and 2, right? And then I'm just going to take the first index here, 4 underscore in range environment. Oh, did too much. Environment.maxsteps, right? And so all this did is saying, hey, instead of learning every time from our environment, let's just pick randomly. And last, we're going to say the random strategy rewards equals random underscore strategy underscore episode for underscore in range episodes. So that is pretty much it. Let me run this to make sure it's working properly. Okay, episodes is not defined. Maybe I have to run these different ones, so I'm gonna just run them. Trading environment is missing one argument, stock prices. Okay, so it's saying that the stock price isn't given here, and so if I go to the very bottom, so this is here in the stock trading. This is the part before, so we should probably run this. But yes, I actually indeed have to set the Tesla prices. So I do Tesla prices. Object has no own stock. Trading environment doesn't have own stock, and so here I just did a typo, and so here it's worked all good. Int object is not callable, so here chosen action. It's because I've actually defined it twice, I believe. So here the chosen action here, I actually should write like choose action. Maybe I just recall this. And so that is the function. And so if I write here, has no own stock, so it shouldn't be own stock, it should be owns stock. So owns. And there we go, it's actually running and thinking. So, and what we're going to do here is that we're looking at the random strategy here. So we have this strategy that creates randomly here different outcomes. And if we run this, it should be able to run, but I might actually have to run everything again. So I'm just going to click run all, and it should run pretty much everything. So it says Tesla prices is not defined, but if I do run all, so here it says the random strategy method object is not subscriptable. So I think I might have written this down slightly incorrect. Let me double check. And so I think I should have put this another brackets out, but oh, here if I click sum, I think that's it. So sum random.choice. Let me just double check that I have everything right. And I have to do random.choice here, and I do another bracket here. And I believe that is how we do it. So we run this, and there we go. It's run it fully. And the last thing I'm going to do is I'm going to plot all of this. I'm going to say, just going to zoom here, and I'm going to write 6, and the final step is let's visualize it all, right? So if I do here plt.figure, this is what we use to plot. We do plot.figure and then fig size, which is the size of the graph land that we're going to use. We do plt.plot and we do range episodes, comma rl underscore agent rewards. So we're going to plot all the agent rewards, and we're just going to do the label basically as it said here, RL agent profit. Now we go to the next one, and we're going to plot, we're going to do plt.gca, and you'll see in a second, .set, and this is how we set the X label and the Y label. So we say X label is the episodes, this is how much times it's gone over the data, and Y label is profit. So that's how we've basically put that together. And we're going to do plt.legend and then we do plt.show. So if I run this already, and I can do command enter to run, or click here, here you can see already per episode the amount of profit that it does. And you see that in 100 episodes, it's actually already starting to make profit. It did a little bit more there, but it's a bit of an outlier. But you can see it's starting to, it hasn't learned much from just 100 episodes, right? So maybe it needs a little bit more time, and we'll give it some more time later. But what I'll do is I want to plot how this looks like against the other training methods. So I'll do plt.figure again. I'm going to copy paste basically all of this stuff. I can probably copy paste this entirely. And so it's 12 by 5. What I'll do before this is let me look at some of the average of the other methods. So I'm going to write average profit underscore for reinforcement learning is np.mean. This takes the average of the RL agent rewards, as you've seen here. Next, the average profit for the holding strategy, meaning we bind, we don't let go, is just equal to the holding profit. And the average profit of doing the random strategy is the mean of the random strategy rewards here. And last but not least, the average profits by strategy equals square brackets, all of these ones together. So there it's basically auto-completed, but those are all of the possible different strategies. So there we go. Now that we adjust this plot, what we have to look at is instead of plt.plot, we're going to do bars charts. So let me just remove all this line and this line, and here I'll do bars. So we're going to do bar charts and do bars equals plt.bar, and basically like in the square brackets it said there, we'll do RL agent hold and then random, and then here we'll do in the brackets average profits by strategy. And then the colors that we put here are blue. Well, we're going to write here blue, red, and green. And there we go. That should pretty much be it. And here we just write as the label strategy, which is the strategy we picked. And here we write average profit. So now last, if I do 4-bar in bars, plt.text, we add some text to it and we say bar.get underscore x plus bar.get underscore width divided by 2 and bar.get height. And then we do f bar.get height, and then we do .2f, and that's it. That should pretty much give us the profits. So I've gotten some error here, unsupported string format to format. I'll just check real quick here. Bar.get width divided by 2, and then if I do bar.get height, and then I do here f bar.get height. I have to call this here. So cool, there we go. There we get the profits. And as you see here, the holding strategy is the best here for Tesla, right? A lot of these stocks you'll find that just holding the stock was probably the best thing. And it's actually a little bit worse than random, this reinforcement learning agent, which you're like, okay, then this agent may have not been that good, right? But one thing that you find is that holding a stock, if that stock has gone up a lot, like Tesla, holding might be the best strategy, which is what a lot of people talk about. One mistake that I found is that here in the round function, we want to make sure to put this -4 inside here, and that's how we're going to round it to 4 decimal places. Another mistake that we have is that here in the NP max, we want to, instead of taking the NP max of here, we want to take it of the Q table, which means we're taking the maximum value of the next state. And that is basically what we want to look at and apply. And one thing that you might have noticed is that we wrote episode wrong here. So when we do the prints, we're writing episode, I believe. And so now if we basically go back to the Tesla example, and if I do it for 10 episodes, like 100 episodes, and then we run all of these versus 2,000, we'll show you what the difference is. And we'll basically see, has anything been learned? So if I go down here, as you can see, it's pretty steady, the profit according to the episode, which isn't great. But you see here that it's already started learning, right? And it's a lot better than random, which is good. It's not quite at the holding strategy, but it seems to have learned quite a bit of things. Now, if we scale the episodes to 2,000, and here we run all of these, so it's going through those 2,000 examples, and that's why it's going a little bit slower. But here you can already see that it's learning quite a bit, it seems. And as you can see here, over the episodes, it hasn't necessarily maybe learned tons. Maybe there's a very slight upwards trend. But as you can see here, the average of the reinforcement learning agent seems to be similar to the holding strategy, perhaps because it's learned over time that holding was the best decision, right, for the majority. I hope you found that interesting, learning reinforcement learning with me. Stay tuned. In the next video, I want to look at reinforcement learning with neural networks. So stay tuned to that if that's something of interest. And if you want to play around, I'd try different stock prices, different time periods, adding different variables here, potentially adjusting some of the hyperparameters, and have fun. Hope you enjoyed this video and have a good rest of the day. Thank you.